because it's a 49 and a 4, is rewrite it as a square, right? And I'm also going to know what the center of this is. Now I can easily sketch it. I've got it centered at a -2, 3. I'm going to go left 7, right 7, and then I'm going to go up 2, and I'm going to go down 2. This is a quick sketch. All I've got to do is label these points and it's accurate. I've labeled the vertices and the center. It's done. Right, this is an interpretation problem. Key here, center intersects two lines. These two lines, right, would be perpendicular. In fact, right, they'd have, so 3, here's the line x equal to 3. Here's the line y equal to -2. In other words, that's the center. So 3, -2 is the center. And then look from here, it says the major axis length is 26. And the minor axis length is 14. This actually isn't enough information for the problem, so let's fix this. We'll say that the minor axis is horizontal. There we go. If the minor axis length is 14 and it's the horizontal, that means that from here to here, like that whole length of the ellipse, right, is going to be 14. So half of it, right, so I'm going to go 14 over 2. I'm going to go left 7, right 7. Same thing here. This would be vertical. I'm going to go up 26 over 2. So that's 13, down 13. It's a sloppy sketch, but it's telling me to determine the equation. So I know that it's going to be x minus 3 squared. And since the x, right, is the horizontal, and that's the minor length, this distance is 7, so 7 squared plus y plus 2 squared over 13, right? 13 squared is 1. There it is. So here what I've done is simply labeled the distance. This distance is 4, this distance is 5, right? The 5 is the longer one. I'm centered at x minus 5, y plus 3. The x distance, how much is it? Yeah, it's 4 squared. Y distance, 5 squared. Boom, done. For the next problem, this guy, 4 squared, 12 squared. Centered at 3, -1. Right, left 4, right 4, up 12, down 12. That's the kind of thing you need to do. Get that done. All these vertexes, which I can do by just, right, adding 4, subtracting 4, adding 12, subtracting 12 to the appropriate thing, right? So adding 4 to the x value, right? So 3 plus 4, that's 7, -1. 3 minus 4, -1, -1. And then, right, what's changing here? Not the x, but I'm going up, right? So I'm going to add 12 to a -1. Down here, I'm going to subtract 12 from a -1. There it is. Vertices are labeled. Now remember, the foci, those come from the distance, rather, right? The distance, so like they would be probably around here. They're always on the major axis. The distance comes from taking that bigger value, subtract the square of that, subtracting the square of the smaller value. Let's compute that, or simplified. So 8 squared sub 2. Now remember that the foci are along the major axis, so what's not going to change? Right, the 3, that's going to be the x-coordinate, that's not going to change either time. But what am I doing each time? Well, I'm going up this length, I'm going up 8 squared sub 2. I'm starting at a -1. I go up that much. I started at a -1. Now I'm going to go down 8 squared sub 2. And those are my foci.